Hi there and welcome to Science 9. This is the first day in our chemistry unit, and this year we're going to study atoms and elements. The first lesson that we're going to talk about is parts of the atom, and this is just a general outline. We may deviate from that, but it gives you a little bit of structure going forward. When you get to class, we're going to try to do some Kahoot games. Last time you were in class, we should have copied down these terms to know. If you haven't had a chance to do that yet, you can fill in pages 3 to 4. I'm going to read through those terms now just to kind of refresh your memory on them, but feel free to pause the video if you're not done copying them down before I move on. It's really important that you have the terms down. So the atom is the smallest unit of matter that can take part in a chemical change. It's the smallest piece of an element. Atomic number is found on the periodic table, and this tells us the number of protons in the nucleus. Atomic mass, or the mass number, we're going to use those two terms interchangeably here in Science 9, is the mass of an average atom of an element, and it's measured in atomic mass units. I've actually given you a mass number on your periodic table just to skip a step for you, help you out a little bit and round those numbers off for you already. So I've already rounded them for you. A proton is a positively charged particle found in the nucleus of an atom. A neutron is a particle carrying no electric charge, forming part of a nucleus of an atom. And the electron is a negatively charged particle found orbiting the nucleus of an atom. The nucleus of the atom is that center part of an atom, a core. All the mass is found here, so it contains the protons and the neutrons. Electrons are found orbiting the nucleus, like planets kind of orbit the sun, in what we call electron shells, orbitals, rings, and this is the path of the given electrons as they travel around the nucleus. The electron shells can hold the following number of electrons in this class. So starting closest to the nucleus, that first shell can hold 2, the second shell can hold a maximum of 8, and for our class here, the third shell can hold a maximum of 8 as well. So we're going to fill in the blanks as we do our notes now. So chemistry is the study of matter, or it's the study of atoms and how they interact, and a chemist is someone that studies chemistry. You should have talked about matter in grade 7 science when you talked about the kinetic molecular theory and those changes in state from solid to liquid to gas. This lesson is going to focus on the atom. So as I mentioned before, atoms are the smallest part that an element can be broken into and still retain properties of that element. So all atoms are made up of 3 subatomic particles, and that prefix sub means below. So we've got protons, they've got a positive charge. Neutrons have no charge, or they're neutral, we say, and electrons have a negative charge. So we're going to look at those 3 basic subatomic particles in a little more detail now. So electrons, and if you see at that picture in the bottom right side, electrons are the tiny one at the bottom. They are the smallest part of an atom. They have a negative charge, and they orbit the nucleus of an atom in those rings, like planets orbit the sun. The number of electrons is equal to the number of protons. Protons have a positive charge. They're found in the nucleus of an atom, that's that dense center or core, and the number of protons is equal to the atomic number, and we can find the atomic number on the periodic table, and this is the top number. So I've given you a sample of a periodic table square. So I've given you in the bottom left corner here a sample square from a periodic table. This is actually the key from your periodic table. So that top number in the top left corner, that's the atomic number. Then we find a symbol, the chemical symbol, the atomic mass, and at the very bottom, the name of the element. Neutrons are the last subatomic particle we're going to talk about. They are a particle that carry no or 0 electric charge. They're said to be neutral, and they're also found in the nucleus of an atom. So if we look here at this picture here, we have neutrons. They're large with no charge. Protons are large with a positive charge, and then electrons are small with a negative charge. So we've given you, right under the words fill in the blank there, I've given you kind of a representation of an atom. So we see that neutrons and protons are found together in the nucleus. And then we have this electron shell or ring where we find all the electrons. So all of the mass of an atom is found inside that nucleus. The electrons are practically weightless. Okay, so if all the mass is found inside the nucleus, that atomic mass or that mass number is going to be the number of protons plus the number of neutrons. So if we wanted to find out the number of neutrons, it's going to be that mass number or that atomic mass minus the number of protons. So we do have to do a little bit of math to figure out how many neutrons there are in an atom. So let's draw an atom together, and we're going to practice this over the next few days. So if you want to copy this down into your notes for me, please. You see the black circle in the center. That's got a P, that stands for protons, and a little positive sign, that's because they're positive. Then we've got an N, and that's got that 0, that's because they have no charge. And that black ring represents the nucleus. So it contains the protons that are positive and the neutrons. In blue, we've got the orbitals, energy levels, electron shells. They've got lots of different names. And we've drawn 3 rings. The first ring can hold a maximum of 2 electrons. The second ring can hold a maximum of 8 electrons. And the third ring can hold a maximum of 8 electrons as well. Electrons are in red. I've given 2 in that first ring because that first ring was full. Then I moved on to that second ring, and I've put 2 in that second ring as well. I've also put a little negative sign beside the electron, or the E, to remind me that electrons have that negative charge. So as we're summing things up here, if we talk about the subatomic particles, or those things inside the atom, protons have a positive charge. They're found in the nucleus. And if we want to find out how many protons an atom has, we look at that top number, or that small number on the periodic table, called the atomic number. Protons have a mass of 1 AMU, which stands for atomic mass unit, and the number of protons can never ever change. Neutrons have a neutral or no charge. They're found in the nucleus of an atom, and in order to find the number of neutrons, we need to do a little bit of math. So we take the bottom number minus the top number, the big number minus the small number, or the mass minus the atomic number. Whichever one of those makes the most sense to you, or you can remember looking at the periodic table, that's fine. The mass is also 1 atomic mass unit, and the number of neutrons can change. And if it changes, we call those isotopes. Electrons have a negative charge. They're found orbiting the nucleus in those shells, orbitals, energy levels, rings they're sometimes called. And the number of electrons will equal the number of protons in a neutral atom. So for grade 9, the electrons equal the number of protons, but in grade 10, we talk more about ions than atoms, so then the electrons won't be equal. Electrons in our course are basically weightless. Their mass is so small that we're going to say they're negligible, they weigh 0. And the number of electrons can change, and if an element or an atom has a positive or negative charge, then it's referred to as an ion after that. So just a little bit more on the atomic mass. That's that mass number. It's the average mass of an atom of that element. So it's the sum of the number of neutrons and the protons in the nucleus of an atom. It's rounded to the nearest whole number. So that nearest whole number, that's the mass number. Isotopes are atoms of the same element. So they have the same number of protons, but they have a different number of neutrons. And the atomic number, that's that top number on the periodic table, that's always going to equal the number of protons in the nucleus of an atom. Okay, so because we know the number of protons and we know the mass, we can use that to calculate the number of neutrons in an element. So the number of neutrons is equal to the mass number minus that atomic number, or that number of protons. So if we look at this example here, we see sodium. The symbol for sodium is Na. You'll notice it's always a capital letter, and then it's always a lowercase if there's a second letter. The atomic number for sodium is 11, and you'll notice at the top of the page in red, I've got the number under sodium as being, the mass being 22.9897. And that's correct. On your periodic table that I've given you in class, I've already done the rounding for you just to make things a little easier. So I've already rounded that off to 23. So depending on what periodic table, you may have to round it. I've made that step a little easier for you. So the top number, that atomic number is 11. Our atomic mass or mass number is 23. So if I want to know how many protons there are, that's going to be equal to my atomic number. So if my atomic number is 11, the number of protons is also 11. It's the same as the atomic number. My number of electrons is equal to my number of protons, or in this case, equal to that atomic number, so it's also 11. So I've got neutrons there in bold. You've got to do a little bit of math. You've got to take that bottom number, that 23, minus that top number, which is 11. So 23 minus 11 is 12. Feel free to use a calculator if you're not super confident in your math skills. So I want you to pause the video right now and use the periodic table in your booklet, either at the front of your booklet or the very last page of your booklet. And I want you to see if you can fill in this chart that I've got on this page. It's also in your booklet. So pause the video now, take a few minutes and fill in that chart. Then we're going to check our answers. All right, so here's the answers. If we're looking at boron, that's the first element, you were given the name of the element. The symbol is a capital B. In order to find that atomic number, I've got to look on the periodic table, and that's going to be 5. That's that top number. The mass, the atomic mass, that's the bottom number, that's 11. If my atomic number is 5, I've also got 5 protons. I've also got 5 electrons, so those are all the same. In order to find my number of neutrons, I've got to take the mass, that bottom number, minus the top number, so 11 minus 5, and I get 6. Sodium's the next one. We did that one together. Symbol's Na. Again, if there's 2 letters in the symbol, it's always capital and then a lowercase. Atomic number is 11. Atomic mass is 23. I've got 11 protons, and I'm going to skip over, go to 11 electrons, and again, I've done some math for the neutrons, 23 minus 11, so I've got 12 neutrons. This next one, for sulfur, I actually only gave you the symbol, so you had to find the symbol S, capital S, just one letter, so it's always in uppercase, on your periodic table. So when we find the S, we can find the name, we know that it's sulfur. We can find the top number, that atomic number, that's 16. The bottom number, that mass, is 32. So if I know my atomic number is 16, I've also got 16 protons and 16 electrons. I'm going to go back to the neutron column. That's where I need my math. Bottom number, 32, that atomic mass, minus the top number, that atomic number, that a number of protons, which is 16. So 32 minus 16 is also 16. So you'll notice the protons, neutrons, and electrons in this case are also 16. The very last row here, I tricked you a little bit. I only gave you the atomic number because the atomic number for every single one of the elements on the periodic table is different. So the atomic number is 26. I need to go through my periodic table till I find the top number of 26. When I find that, I'll know that that's iron, and the symbol for iron is capital F, lowercase e. Once I know my atomic number is 26 and I found iron, I can look up that bottom number on the periodic table, that atomic mass. That's 56. Because I know the atomic number, I know the number of protons, 26. I know the number of electrons, 26. And again, to find my neutrons, I've got to do a little bit of math. 56 minus 26. Again, use your calculator if you need to, and that becomes 30. I hope that's helpful. Thank you for watching the video. When you come to class tomorrow, we're going to go through the assignment, and we're going to practice this a little bit more in class, so hopefully everybody's proficient in it by the end of class. Take care.